Calculus Lesson 1, Limits. This should be pretty easy, so let's get started with it. So, we've got a function, 3x plus 1, and the question asks us to find the limit as x approaches 2 of this function. What does this ask us? This asks us basically what value of y is the function approaching when x approaches 2. So to find the limit, we have to approach the function from both the left-hand side and the right-hand side. So if we approach the function from the left-hand side, starting from here, if we go from here towards 2, where 2 would be somewhere around here, if we approach the function, we would approach this point right over here. And what this point is, simply from functions, we know that whatever x value we put in, we get that y value. So that would be 3 times 2 plus 1, which is 6 plus 1, which is 7. If we approach the function likewise from the right-hand side towards 2, we would also approach 7. And hence we say that limit as x approaches 2 for 3x plus 1, it's simply going to be 7. And now we know that, okay, we can find the limit just by simply putting in the x value right over here to here, right? Well, that's not always the case, and it doesn't really work all the time. So suppose we have limit as x approaches 1, the function x squared minus 1, x minus 1. Now if we go ahead and substitute this one right over here to here, and here as well, we'll see that it's 1 squared minus 1 over 1 minus 1. And this is 0 over 0. Now we know that in mathematics, this does not exist. But what we can do is, we can also simplify our expression. So I'd say limit x approaches 1, from the differences of squares, we can say that this is the same as x minus 1 times x plus 1 over x minus 1. And then x minus 1's cancel out, we're left with, and here now we can substitute this 1 to x right over here, and it's going to be 1 plus 1, and it's going to be 2. Easy. Then we got the third type of limit problems. Now these ones are a bit more complicated, but it doesn't really get more complicated than this. So to find the limit when we have square roots in our expressions, we want to rationalize our expression. And so here's how we rationalize the square root. Same thing, x square root of x minus 2 over x minus 4, and then we multiply it by square root of x plus 2 over square root of x plus 2. And now by multiplying the fractions and simplifying them, on the top we get x minus 4, and on the denominator we get x minus 4 multiplied by square root of x plus 2. Now we can cancel. We would get 1 over square root of 4 plus 2. And so this is our limit of this expression as x approaches 4. And now one last thing to consider with limits is when limits do not exist. Well, how to find when limits do not exist? For instance, you are given f of x and you're trying to find the limit as x approaches 2 of some function f of x, right? Now, if you approach the limit from the left-hand side, you're going to approach some value, let's assume 1, right? However, if you approach 2 from the right-hand side, you're going to approach some value, which is, say, 5. And then you're going to see that, okay, when I approach from left-hand side, when I approach from right-hand side, I approach different values of y at the same x equals to 2. And so when you approach different values of y at the same x, this means that the limit of that function at that point x does not exist. And so this, we say, does not exist.